Okay, so this is sample problem 8 by 2. The 8 kg body uh, is m- um, is moved zero point 0.2 meter to the right of the equilibrium position. So mass is given, which is 8 kg. Uh, Move to the right zero point 0.2 meter. This means that at t equals 0, x naught is equal to zero point 0.2 meter. So this is initial condition here. Uh, and release from rest at t equal to 0. So this means that x naught dot is equal to 0 meter per second. So the initial velocity is 0 and the initial displacement is 0.2 at time t equal to 0. Determine the displacement at time t is equal to 2 second. So you need to calculate the displacement when x is equal to 0.2 second, x is equal to 2 second. So x2 is unknown here. The viscous damping coefficient C is given, which is 20 Newton second per meter, and the spring constant K is given, which is 32 Newton per meter here. This is the these conditions are given. So and you need to calculate the displacement of this system when x is equal when time is equal to 2 second here. So to find out the solution of this system, first we need to find out that the system is which type of damping is here. Is it critically damping, is it over damping, or is it under damped system? uh, so to find out so solution, find out the type of damping. So you need to calculate this zeta here, which is c divided by 2m omega n. Now we can calculate omega n, which is k divided by m under the root, and which is 32. So k is 32, and m is 8. So this will become equal to 2 radian per second. So this is the omega n. So now you can calculate zeta. So c is given, which is 20 divided by 2 into 8 into omega n, which is 2. So from here you can calculate zeta, which become equal to 0.625. This means that the system is under damped system. System is under damped here. So now we know from the from our theory part that if a system is under damped, so then we know the solution of the system, which become equal to c e power minus zeta omega nt and sine omega dt plus psi. So this was the solution of the system when it is under damped. Okay, so now this is the x, and we need to calculate x when t is equal to 2 second. But obviously, in this case, we know zeta, we know omega n, but we also can calculate omega d here. So omega d is, we know the equation of omega d, which is omega n 1 minus zeta square. So if you just put the value of omega n, which is 2, and omega and zeta, which is in this case it is 0.625 square. So this will become equal to 1.561 and radian per second. This is the value of the omega d. Um, But now in this equation, there are two constant. One is c and one is psi here. We also need to calculate these two constant. If we just put all these known values in this equation here, so x will become equal to c e power. So if you multiply zeta with omega n, so zeta is 0.625 and omega n is 2. So if you multiply this, you will get minus 1.25 t, and you already know omega d here, which is this 1.561, and plus psi. So this is the final equation here. But obviously, we need to now calculate t and psi before calculating x2 here. So to calculate c and psi, we will need to use these initial conditions here. So because we are given the initial condition for the displacement and velocity, so we need to calculate velocity first. To calculate velocity, we need to differentiate this equation with respect to time. So to differentiate this equation, so we need to calculate this x dot. So x dot means differentiate this equation with respect to time. So there are two time terms. So one is this time terms and one is this time term. So we will obviously need to use the product rule of differentiation. So minus 125 e minus 1.25 t 1.561 t plus psi, and then for the second case you will differentiate this term here. Sign is here. So it will become equal to 1.561 c e power minus 125 t, and it become equal to cos. So 1.561 plus psi. This is the equation what we get for the velocity here. We have the equation for displacement and velocity. Now if we use the initial condition here, use the initial conditions. So what will happen that x become equal to 0.2, and on the right hand side you will get c, and this thing will become t is equal to 0. So then this term will become equal to 1, and sine and this thing will become equal to 0, but the only thing which will left is sine psi. So this is one equation. You call this equation 1 and call this equation 2. So the equation 1 we get this one, and from equation 2 we get, so from equation 2 what we will get is, if you put velocity here which is 0, and on the right hand side you will get minus 1.25 c, and sine psi, because this thing will become equal to 1 and this thing will become equal to 0. And now for this part, plus 1.561 t, and this thing will e power minus 125 t will become equal to 1. And again this 1.561 t will become equal to 0. It will become cos psi here. So we end up with this equation here. Now from this equation, from equation, so if you call this equation 3 and this equation 4, so equation 4 giving you Sine psi divided by cos psi, it become equal to 1.561 divided by 1.25, so which is uh, just equal to tangent psi. So you can calculate psi here, which is tangent inverse 1.561 divided by 1.25. So from here you will get psi, which is 0.896. So if you have the psi value, now you can calculate using equation 3. You can calculate C because if you know this one, so you can calculate this one. So it will become uh, C sine 96 uh, equal to zero point 0.2. So C will become equal to 0.256. So now we managed to calculate psi and C. So we can put these back into our main equation here, which is this equation here. If we just put the value here, so x become equal to C, which is 0.256, 1.25 T sine, and 1.561 T plus psi. But obviously we know the value of the psi here, which is 0.896. This is the value of the x now. The equation become this equation now. So now everything is given. The only thing that if you just replace time by its value 0.2, so you can get the value of the x here. So now it t is equal to 2 second. X2 will become equal to minus 0.1616 meter. This is the value of the x here.